Welcome to Rges Algebra 2, Lesson 13A. We're looking at lessons 3.6 and 3.7, and the topic will be multiplication and division of fractions. Now recall our basic rules about multiplying and dividing fractions, and that is that if you're multiplying, you would cancel, then multiply straight across. Numerator times numerator and denominator times denominator. If you're dividing, to divide by means to multiply by the reciprocal, convert it to a multiplication, and do the same process. So basically, all I'm going to do is show you several examples. Now, the key to doing this with rational expressions in algebra is that you will want to always factor so that you can cancel. So I'm going to run through many examples for you. So here's my first example, and I just like to go through them one at a time, numerator and denominator. You can make them all one big fraction or leave it separated like it is right now. It doesn't really matter, but you're going to factor everything you see. So I'll first have a squared plus b squared times a squared minus b squared. I'm just going to do all the numerators first. Next I'll have 4a. Next I'll have a minus b. Next I'll have a 1, which really doesn't amount to much of anything. All right, next I'll have a 2 times a plus b. No denominator in the second term. In the third term, I've got a squared plus b squared. I cannot factor. And in the last one, I have 2ab, and that does not factor. Now I go ahead and cancel anywhere I can. So this let's see, that doesn't work here. This a squared plus b squared cancels here. This 2 will go into the 4 2 times. This 2 will cancel with this 2. This a will cancel with this a. Okay, let's see. Whoops. Why did I not break that one out? I apologize. I should have been more careful. But as I'm looking now, I can certainly see that would have factored to, I'll ignore that 1 since it's pretty irrelevant for us, because 1 multiplied by anything is that itself, but a squared minus b squared would have factored to a plus b times a minus b. So I could have illustrated that a little more efficiently. This would cancel with this, and now what have I got? So that, of course, cancels out because that got re-expressed over here. And now I've got a minus b squared, because I've got it twice, here, and only a b in my denominator. Now notice that, of course, that b in the denominator there would never cancel into that because we are first having to subtract these two in the numerator and then square it. And so that would not be canceling. Okay, let's do a lot more. I'm going to do several of the even problems for you. Okay, showing a few more examples here. My 8s will cancel, 3 will go into 6. 2 times. No c will cancel into the denominator. I have 1a down below, taking away the square up here. I have 2 d's up top, taking away the cubed, and with leaving 1 down below, and that looks like all I have. Then making sure you gather them together without missing anything, you're going to get 2ab, or I'm sorry, did I cancel the b? 2ac all over d. For the next one, notice I've got 2 negative signs here and here, so negative times a negative is a positive, so we'll do away with those right away. Canceling anything else, let's see, no x can cancel, one of the z's can cancel right there. This d will cancel down below here, and all I'm left with here is number 8. We've got an x in the numerator and an az in the denominator. Okay, this will give me an opportunity on number 10 to show you a little bit more how to deal with these, I don't know what I would call these, more complex exponents here. Now recall if I just had something simple like x to the 7th over x to the 5, I could have written that out and showed you how that, what that meant and cancel, but we also recall that when we're dividing variables, the exponents are subtracted, so that would be the same as x to the 7 minus 5 or x squared. I'm going to use that idea now rather than writing out excuse me, these expressions here and showing you what they mean. Now I'm just going to focus on the idea that we can subtract them. So for my a's here, I'm going to subtract exponents. So 2n minus n is going to give me n, and 2 minus a negative 2 is going to give me a positive 4. See how that works? Now, in the next one, because my b down in the denominator is more than my b up here, I'm going to start with this one and then subtract the numerator one. So I'm going to go b, it'll be left in the denominator. 3n minus 2n is n, and minus 1, again, I'm going to subtract as I go. I'm going to subtract the one that's across the line. So if I start with the numerator, I'm going to subtract the exponent of the denominator. Or if I start with the denominator, I'm going to subtract the exponent of the numerator. Okay, it goes in both directions. So that's what I'm doing here. I get n, and then finally minus 1, because I'm subtracting, okay, is minus 2. And that's how we do that. And that's actually the more efficient way. I wanted to do it the other way before to give you a feel for what it really meant. Okay, I'm going to try to grab a couple more complex examples and we'll be done with this. Okay, this will probably be the last one I need to do on this section. I'm going to go ahead and remember your factoring. You're factoring every single term here. I'll factor this, I'll factor this, I'll factor this, I'll factor this. Okay, if I need to, if I can. Right? Okay, so I'm going to take away an a squared. I'm going to be left with a minus b. I'm going to take away an ab squared. I'm going to be left with a minus b. I'm going to, I could write this out twice if I wanted to. I don't have to. I could just cancel with my exponents. And I'll take away an a, b, and I'll be left with a plus b. And ab, and I'll be left with 1a plus, yeah, okay, making sure I did that right. Yes, now go ahead and cancel. Let's see, we're going to take away 1a, we're going to take away an a minus b, we're going to take another a minus b away. Let's see, I could take away one of these b's, and I'll be left with a squared b over a plus b. And that's really all there is to it. Now, when you go to divide, you're doing the very same thing on the next section, except that my very first step will change. So let me give you an example of that. My first step will be to change the second fraction when you're dividing. It's the second fraction you divide by to multiply by the reciprocal. So this second one will be the one I will turn upside down or make a reciprocal. So I'm going to, I could go ahead and do that. Yeah, I'm just going to do it quickly. You could convert this to one step, but now I'm going to make this a multiply. Doing the reciprocal now. If you think that you're ever going to be inclined to forget to flip it, go ahead and write it as a secondary step, just like that. Now we're going to, of course, our a cubed formula, or our cube formula, this is going to be a plus b times a squared minus ab plus b squared. Factoring the denominator, I'm going to get a plus b times a minus b. In the next term, factoring the numerator, I'm going to get a minus b. There's no factoring going on there. And in the next one, I'm going to get nothing. So, okay, now looking at my canceling, the a minus b's will cancel, the a plus b's will cancel. That's all we have. And we're going to get a squared minus ab plus b squared all over a squared plus ab plus b squared. And I don't know that we need to do any more examples right now, because all you're doing is changing it from a division to a multiplication and continuing on just as you did last time. So that's pretty straightforward, I think. It just gives you lots more practice with the same idea. All right. Do your work carefully, watch out for signs, be careful with details, and hopefully you'll do just an excellent job with this, and we'll see you on Wednesday.